Solve the logarithmic equation for the variable m. Notice in this equation we've got logarithms on both sides. But we can't set the arguments equal to each other because we don't have just a single logarithm on the right. This plus 2 prevents us from being able to do that. So let's think about how we might go about condensing into a single logarithm, and essentially what we'll want to do first is get our logs together. And once both logarithms are on one side, then we can condense them into a single logarithm. So let's start by subtracting the ln of m minus 3 from both sides. The ln's cancel out on the right, and on the left we'll have the ln of 3m plus 1 minus the ln of m minus 3. And on the right-hand side, only 2 remains. Now that we have both our logs together on one side, we're going to condense using the quotient rule. As a reminder, the quotient rule says that if we have two things divided in the argument of a logarithm, that can be split into the log base a of the top minus the log base a of the bottom. So we'll use this quotient rule in reverse and condense into this single logarithm. So we get the ln of 3m plus 1 is in the numerator and m minus 3 is in the denominator. And we're still equal to 2. Now in order to solve for m, where the m is trapped in the argument of the logarithm, we'll need to convert to exponential form in order to liberate that m or to make it accessible. Remember, the ln, or the natural logarithm, is the same thing as log base e, so we'll take our base e, raise it to the 2 power, and then set that equal to this argument. So we have e squared is equal to 3m plus 1 over m minus 3. Now it's time to reassess. Since the m's are no longer trapped in the argument of the logarithm, what we have now is a rational equation. And one way of solving this rational equation is to multiply both sides by the LCD. In this case, the LCD is m minus 3, so we multiply both sides by m minus 3 over 1. On the left-hand side, we have e squared times m minus 3, and on the right-hand side, these m minus 3's cancel out, which leaves us with just 3m plus 1. Now it's time to reassess again. And what we'll notice here is that we actually have a linear equation. This is not quadratic. E squared is a constant. We treat it the same as we would if it were 3 squared. This is a linear equation because the variables, which are m, are raised to the first power. And in order to solve a linear equation, we're going to get our variables to one side and our constants to the other. But in order to identify our variable terms and our constant terms, let's distribute that e squared into the parentheses, and we'll get e squared times m minus 3e squared is equal to 3m plus 1. The variable terms are the ones that contain m's. Negative 3e squared is a constant, and 1 is a constant. So we'll get our variable terms together on the left and move our constant terms to the right-hand side. So let's subtract 3m from both sides and add 3e squared to both sides. And what we now have is e squared times m minus 3m on the left and 1 plus 3e squared on the right. And although it's a little bit tricky to see, what we have now are our variable terms on the left and our constant terms on the right. In order to solve for m, let's notice that we have an m in common to both of these variable terms on the left. So let's factor out that common m. So we'll have e squared minus 3 that remains, and we have 1 plus 3e squared on the right. Now, in order to solve for m, all we have to do is divide both sides by this constant quantity, e squared minus 3. We can cancel these constants because we're canceling over multiply, so we'll end up with just m on the left. But we cannot cancel anything on the right because we can't cancel over add or subtract. So this constant on the right-hand side, I'm going to rearrange it just a tad to say 3e squared plus 1 over e squared minus 3. This constant would be our final answer. However, we definitely want to check this answer, especially because the beginning equation was logarithmic, and logarithmics sometimes generate extraneous solutions. But we definitely want to use our calculator here. Checking this by hand would be pretty difficult. So in the calculator, let's select alpha F1 in order to get the numerator-denominator feature. So we hit enter and we end up with the fraction on the home screen. We'll then input 3e squared, so 3 second, and then e raised to a power is here, so we'll hit the ln button, but we're actually getting the e raised to a power function. So that's 3e squared plus 1 in the numerator. And then come down, again we'll say e squared, and then minus 3 in the denominator. Come out of this, and let's hit the store button down here, and we'll store all of this into our x variable in the calculator, which will make our answer easy to access. So hit enter, and we get that decimal approximation for this irrational number. Then we want to input this value back to the very beginning equation, which was the ln of 3m plus 1, but we have it stored in x, so we'll say 3x plus 1. Close the argument. We want to see what the left-hand side is with our solution stored in for x, and compare that to the right-hand side, which is 2 plus the ln of our answer stored into x minus 3, and then close the argument. When we hit enter, we see that the two sides do match, which tells us that our answer is a working solution.